Hello everyone, I'm TungLe. Now I'm going to present the BIS attack and its implementation. From crash test security, BIS attack stands for Browser Exploit Against SSL TLS. Is an attack that exploits a vulnerability in transport layer security version 1.0 and other TLS protocols using cipher blockchain encryption mode. Basically, this attack allows the man-in-the-middle adversary to uncover information from an encrypted SSL TLS 1.0 session. So our setting will be a user interacting with a web server via an encrypted channel using SSL or TLS. And there is a man-in-the-middle attacker who can intercept encrypted messages from the user and inject messages himself into the communication channel. The high-level idea of this attack can be described as follows. The attack happens in the setting in which an attacker can sniff a TLS 1.0 session and can inject data into it. The attacker then modifies the eavesdrop ciphertext from the victim and injects modified messages into the session to check the invalidity. The attack is performed with each small part of the ciphertext message, such as 1 byte at a time, and repeated to discover the communication content between the user and the web server. We suppose that we all know about block ciphers, such as AES and DES. To encrypt data of arbitrary length, there are schemes proposed to integrate with block ciphers, such as electronic code block or ECB, cipher blockchaining or CBC, and counter mode, etc. This attack occurs in protocols that use CBC mode, so now we are going to have a look at how CBC works. This is a diagram of CBC encryption mode, so the original message is split into many smaller message blocks, M1 to M5 here, and IV is a random value. With CBC mode, the message must be a multiple of B bytes data blocks, and if it's not the case, then padding will be performed. By PKCS5 standard, the last block of the encrypted message is padded with n bytes of value n to be an exact multiple of the block length b. For example, we suppose that M5 is padded with 2 bytes, and the values of these 2 bytes are 0x02, which is value 2 in decimal. So the ciphertext will be encrypted message blocks and enclosed with the chosen random value IV. This is a diagram of CBC decryption mode. It is reversed from the emission diagram. As we can see here, the ciphertext of the previous block is XOR with the decrypted output of the current block, and this leads to the problem of CBC, where the adversary can create the desired plaintext by modifying the ciphertext. And this is also the reason of this attack. So suppose that the adversary would like to learn plaintext M4 from the ciphertext. The adversary first removes the last block C5 and only considers blocks C1 to C4. Let G be a guess value for the last byte of M4, and G will be in the range from 0 to 255. The adversary then takes the last byte of C3 and XOR it with the guess value G and padding value 0x01. Obviously, this will cause an effect on the plaintext M4. So the plaintext M4 after decrypted will be the last byte of M4 XOR with G and XOR with the padding value 0x01. And in older versions of TLS, the adversary is allowed is announced about whether the padding is correct or not. If she is correct, then these two values will be cancelled out, and the padding will be correct, which is one byte of value 0x01. Otherwise, the padding will be some other value, and the adversary will know that she is a wrong guess value. Following the description above, the adversary now sends a modified ciphertext to the web server. Then the web server will return a reply back to the adversary to let him know whether the padding is valid or not. And this process is repeated again and again for every guess value from 0 to 255 until the correct value is found. After learning the last byte, the adversary uses the discover value to guess the next byte. In particular, suppose that each plaintext and ciphertext block consists of 16 bytes numbered from 1 to 16. After discovering the last byte of M4, denoted as M4, 16 here, the adversary will guess the second to last byte of M4 by XORing the two last bytes of C3 with guess value concatenated with M4, 16 and with padding values 0x02, 0x02, and similar for other bytes. So to implement this attack, firstly, we need to learn socket programming, and as we choose C++ in Windows environment, we learn how to use WinSock library to develop network applications on Windows. Secondly, we looked into how HTTP works and the syntax of HTTP requests, as well as tried some examples of sending HTTP requests using socket library. Finally, we also had to debug and test our prototype program to verify that it works correctly. About our implementation, we prototyped our program using C++ and WinSock library to establish connections, send and receive requests with the HTTP server. In total, our program consists of about 120 lines of code. Our program demonstrates an example attack to decrypt an intercepted ciphertext. Our demo works as follows. We suppose that there is a man-in-the-middle attacker who can intercept a ciphertext between a user and a web server. Because the message is encrypted, the adversary cannot understand its meaning. Therefore, the adversary performs this attack with the web server to decrypt that intercepted message. At the end of the process, our program or the adversary learns the content of the ciphertext as here. Now let's see how our attack program runs. So because the attack proceeds in the reverse direction from the last byte to the first byte, the exploited plaintext will also be reversed by characters like this. To make the video not too long, I'm going to pause it and continue after the program nearly ends. So now our program is about to end. So as you can see, the plain text has been decrypted here. So countermeasures. The demonstrated attack that we present above can succeed because the attacker is announced about the validity of the ciphertext. In particular, the adversary can differentiate between two cases. That is, when the path is invalid, the web server returns 403 error code, meaning forbidden request, and when the CPC pathing is valid, but the message is malformed, the web server returns a 404 error code, meaning URL not found. So the first countermeasure to prevent this attack is that the web server should not explain why the decryption fails. Instead, it just returns a common error when there are failures. This attack happens with CPC mode, thereby using other modes such as counter mode can prevent this attack. In conclusion, in this work, we perform the following. First, we present the high-level idea of BIS attack. Then, we explain how BIS attack works with visualizations. Next, we implement and demonstrate our example program which performs BIS attack to decrypt an intercepted message. Finally, we list several typical countermeasures against BIS attack. This is the end of my presentation. Thank you for your attention.